All right, so welcome back. We're going to go through another example in our discussion about confidence intervals. So a recent survey asked a random sample of 2,000 US adults if they ever used Twitter. Of the sample, 19% said yes. According to the survey, the resulting 95% confidence interval is as stated. Interpret the confidence interval and the confidence level. Also identify the standard deviation of the sample and of the population. All right. So this is how let's actually see if you can come up with this yourself. You can pause it. And I'm going to give you the answer. All right. So confidence interval, we are 95% confident that the interval from 0.167 to 0.213 contains the actual proportion of US adults who use Twitter. All right. Confidence level in 95% of all possible samples of 2,253 US adults, the resulting confidence interval would capture the actual population proportion of US adults who use Twitter. All right, so if we sample 2,253 US adults 100 times, then we know that 95% of them would contain the actual population proportion of US adults who use Twitter. Right, so we need to make those statements properly for confidence interval and confidence level. All right, so identify the standard deviation of the sample and the population. We know that 95% is 2 plus or minus 2 standard deviations from X bar. We can find X bar by taking 0.167 plus 0.213, dividing that, adding that together, dividing by 2, and then we get so we can take the value for 0.19 as the mean, or we can add these two values together and divide by 2. What we want to do is we want to find the standard deviation. So we're going to take the upper limit in the interval. We're going to subtract the mean from that value to get our 2 standard deviations. Divide by 2, we end up with 0.0115. That's our sample standard deviation. And then we're going to use that to figure out what the value of the population standard deviation is. Now by solving for the population standard deviation, here I have 0.115 is equal to the population standard deviation divided by the square root of the sample size, which is 2,253, and I end up with a standard deviation of 5.46. So I'm backing out that value. So once again, confidence interval stated we are 95% confident that the interval from 0.167 to 0.213 contains the actual proportion of US adults who use Twitter, and the confidence level in 95% of all possible samples of that given size, 2,253 US adults, the resulting confidence interval would capture the actual population proportion of US adults who use Twitter. All right. So this brings us to your second homework problem. So I'm going to change this. According to a Gallup poll, 4,655 citizens, the 95% confidence interval for a true proportion of Americans who approved of the job Barack Obama was doing as president was 0.44 plus or minus 0.03. Interpret the confidence interval and the confidence level. Then identify the sample and population standard deviation. All right, so I'm going to let you copy this down, and then I'm going to move on. All right, so next topic I want to discuss is constructing a confidence interval, and then we'll end with using confidence intervals wisely. All right, so going back to our discussion about Twitter and the polls that we discussed. So we want to interpret the confidence interval and the confidence level. And so I'm giving you a graphic representation of the distribution, which is normal or normalized, by showing you where that sample mean is, which is equal to the population mean, and then plus or minus 2 standard deviations to 0.167 and to 0.213. And then we said that we know that in 95% of these samples of 2,253 U.S. adults, we're going to end up with a value that represents the population mean. All right, so here's a sampling distribution. Here's a normal curve. The true population means is going to fall within this interval 95% of the time that we run the sampling of the 2,000 adults. All right, so there's that interval that we talked about. Now, what happens to the interval if we want our confidence level to be 68%, which is plus or minus 1 standard deviation? All right, so here's the original interval, 0.167 to 0.213, and now we're going to move that standard deviation in. All right, so a 68% confidence level or interval would result in narrowing the band or making that interval smaller, not wider. So I think part of the misconception is thinking that if we make the confidence interval looser, then the interval gets wider, but in fact gets narrower, because what we're saying is what is the percentage of time that the sampling will, within a given range, find the true population mean. And in this case, when we make the confidence interval lower, we're narrowing that interval. So now the interval becomes 0.1785 to 0.2015, which was narrower than 0.167 to 0.213. Okay, so just a graphic representation of what happens when you decrease the confidence percentage. You're narrowing also the confidence interval. All right, so confidence interval is equal to the estimate plus or minus the margin of error. And the margin of error is a critical value times the standard deviation. And the critical values for 68% confidence is 1. So we're going back to our empirical rule. 95% confidence is 2. And 99.7% confidence is 3. So we're just looking for the standard deviations in this case as a critical value. All right, so the bounds of the confidence interval are set by the number of standard deviation from the statistic. The critical value is the number of standard deviations from the statistic point estimate. And then that margin of error is going to be that critical value times the standard deviation. All right, so this brings us to homework 8.1.3. All right, so in Mr. A's AP Stats class, an SRS of 20 boys and 20 girls were asked how many shoes they have, a 95% confidence interval. The difference in the population means girls minus boys is 10.9 to 26.5. So I need for you to find the sample mean of the difference, sample standard deviation, population standard deviation, interpret the confidence interval, and interpret the confidence level. So I'm going to give you a moment to write all this down. And then I'm going to move on. Okay, moving on. All right, so just as a summary, if we want a smaller margin of error, then we need to either reduce the confidence level or we need to increase the sample size and therefore reduce the standard deviation. All right, so if we need a smaller margin of error, then we need to either reduce the confidence level or increase the sample size. So typically we don't want to reduce the confidence level. What we want to do is we need to increase the sample size. All right. So let's talk about using confidence intervals wisely. Of course, we want to talk about conditions for constructing a confidence interval. So random, normal, and independent. So we need to make sure that the data comes from a well-designed random sample or randomized experiment. Normal, the sampling distribution of the statistic is approximately normal. We talked about last time even if the distribution of the statistic is not normal, then the sampling distribution where that value is greater than 30 will mean that the sampling distribution is going to be approximately normal. And then we want to check for independence, and we use that 10% rule, right, where in this case the sample size is less than or equal to 1/10 of the population size. All right. That's going to bring us to the end of this discussion, I believe. There's some activities that I'll have you do as part of class, but we're going to end with these conditions for constructing a confidence interval. You're going to use these as you construct confidence intervals moving forward. Thanks for joining. Come back next time. We're going to talk about estimating a population proportion in the next section.